Okay, welcome back to another installment of the 4.2 notes. Let's go ahead and graph this curve, or this equation, x times e to the negative x. And so I'm going to come in here and do the curve sketching guide. The first thing I'm going to do, is come in here and rewrite my function as x times e to the negative x power. Okay, the domain of this function, I can plug in any number for x. Okay, I can plug in from negative infinity to positive infinity. Okay, the range, that's something that we're going to take a look at. We don't really need to know that per se. I'm not really going to talk about that too much. But let's go ahead and find our x-intercepts. And so what I want to do is I want to set our equation equal to 0 and solve for x. So x times e to the negative x. I can set x equals 0, okay, and I can set e to the negative x equal to 0. This is my only value for my x-intercept, so I do have 0 on there. That is an x-intercept. There is no solution for this, okay, so we don't have a value. We just have x equals 0, okay. The y-intercept, I'm going to go ahead and plug 0 in for y, or for x, I mean. And so we get y is equal to 0 times e to the negative 0 power, and that's just going to give me 0. Okay, so I have the y-intercept, y equals 0. Okay, and I don't have much of a vertical asymptote. I don't have a vertical asymptote. I have none. Okay, for this function, but I do have a horizontal asymptote. As x gets really, really big, we do approach the y or the x-axis. So I do have y equals 0 as a horizontal asymptote. Okay, so I have all those. All right, but now I want to do the first derivative test. Okay, so I've got I have my function f of x, and I'm going to write it up here. I'm going to say f of x is equal to x times e to the negative x. And so what I want to do is I do want to do the product rule here. And I know that the derivative of x is just going to be 1. So 1, and then the derivative of e to the negative x is going to be negative e to the negative x, okay? And I'm going to cross multiply and add them together. So I get e to the negative x minus x times e to the negative x, okay? And this is my derivative, okay? I'm going to say that that's equal to f prime of x, okay? So now what I want to do with this is I want to set this equal to 0 and solve for x. So I'm going to do 0 is equal to e to the negative x minus x times e to the negative x. And I can factor out a common e to the negative x. So I get 0 is equal to e to the negative x, and I'm left with 1 minus x, okay? So I set each of these equal to 0. I set e to the negative x equals 0, and I'm going to set 1 minus x equal to 0. So here I get no solution, okay? This will never cross the x-axis. But here, I'm going to go ahead and add an x, so I get 1 is equal to x, okay? And that is my critical point for my derivative. Okay, so I'm going to go ahead and write that over here. Critical numbers, my critical point is at x is equal to 1. Okay, so I'm going to go ahead and do my first derivative test here. Now I'm going to split my interval in from negative infinity to 1, and then from 1 to positive infinity. Okay, and that's it. All right, so I'm going to choose a number between negative infinity and 1, and I'm going to choose, say, 0. And then I'm going to choose a number from 1 to infinity, and then I'm just going to plug in 2. Okay, so let's go ahead and plug these into our derivative here. And I'm going to do that over here, and I'm going to do f prime of 0 is equal to e to the negative 0 power times 1 minus 0. Okay, I'm going to plug it into this, my factored form. I find that that's a little bit easier. So from here, f prime of 0 is going to give me e to the 0 times 1, and e to the 0 is just 1, so 1 times 1, and that's going to give me a positive number. Okay, so I'm going to come over here, I'm going to put that this is positive, and I know that we are increasing over that interval. My function is increasing. Okay, now I'm going to go ahead and plug in 2 into my derivative, and I'm going to get f prime of 2, and that's going to give me e to the negative 2 times 1 minus 2. Okay, e to the negative 2, that's just 1 over e squared times negative 1. So I have a positive number here times a negative number, and that's just going to give me a negative number. All right, so I'm going to go over here, and I'm going to put negative, and then that we're decreasing. So at 1, I have a maximum. Okay, I have a maximum value at 1. Okay, and I'm going to come over here, and the extreme values, I'm going to plug that number, find f of 1. Okay, and that's going to give me 1 times e to the negative 1 power. So that gives me just 1 times 1 over e, which gives me 1 over e. So I have a maximum, okay, at the point 1 comma 1 over e. All right, so that's what I've got. I have that point on the graph. Okay, we'll plot that here in a bit. Okay, let's go ahead and do our second derivative. And the one thing I want to do here is write out what our first derivative was. So I'm going to write f prime of x was e to the negative x minus x times e to the negative x. Okay, so if I wanted to find my second derivative, okay, then I would need to do, okay, let me do this. Let me do some work here. Hold on. Okay, I know I'm going to have to do product rule here. Okay, so I'm going to do that first. I'm going to take the derivatives of each of these. So I've got negative 1, and then the derivative here is negative e to the negative x. And I'm going to cross multiply and add those together. So for my second derivative, I'm going to get negative e to the negative x, and that comes from up here. Okay, I have to take the derivative of that using the chain rule. And then I'm going to do this. Okay, I've got negative x times negative e to the negative x. I'm going to do plus x times e to the negative x. And then I've got negative 1 times e to the negative x, so that's just going to give me minus e to the negative x. Okay, I'm going to combine my like terms here, and I'm going to get my second derivative, f double prime of x, is equal to negative 2 e to the negative x plus x times e to the negative x. Okay, and I'm going to go ahead and set this equal to 0 and solve for x. So, okay, I'm going to set that equal to 0. So 0 is equal to negative 2 e to the negative x plus x times e to the negative x. And I'm going to go ahead and factor out a common e to the negative x. So I get 0 is equal to e to the negative x times negative 2 plus x. Okay, and I'm going to set each of these equal to 0. So I've got e to the negative x is equal to 0. And I've got negative 2 plus x is equal to 0. Okay, and so from here, I know I have no solution here because it's an exponential function. Okay, and then I'm going to go ahead and add 2 to both sides, and so I get that x is equal to 2. Now this is a critical point for my second derivative. Okay, so I'm going to come over here, lay out my critical numbers. So I have a critical point, okay, at the value x equals 2. Okay, and then I'm going to create my interval and do my table. So I've got from negative infinity to 2, and then from 2 to positive infinity. Okay, so a good number to choose here would be, say, like say 0 and then 3, and I'm going to plug that into my second derivative. Okay, and so I am going to use the factored form here. I'm going to use this to check that. So I'm going to do f double prime, okay, f double prime of 0, and that's going to give me e to the negative 0 times negative 2 plus 0. And so that's going to give me 1 times negative 2, which is just going to give me a negative value. So I'm going to come over here, and I'm going to put that we're negative. So then my graph then is going to be concave down. Okay, and then what I want to do is check, say, f double prime of 3. So f double prime of 3 is going to give me e to the negative 3 times negative 2 plus 3. And so this is going to give me 1 over e cubed, which is a positive number, times 1, okay, which is just going to give me a positive number. So I'm positive here, and I go ahead and I'm concave up between 2 and infinity. So at 2, I have a point of inflection, okay? Now let's go ahead and plug that into our function. So if I do f of 2, okay, f of 2 is going to give me 2 times e to the negative 2 power. Okay, I'm plugging that back into my original function. So then I get 2 times 1 over e squared. So that's just going to give me a point of inflection of 2 over e squared. All right. So then I have this. All right. I have a point of inflection, okay, at the point 2 comma 2 over e squared. All right. So this is enough information for us to graph, but I'm going to go ahead and do that over here, and I'm going to kind of change my scale up a little bit so that we've got some numbers we can work with. I'm going to call this 1 right here, and I'm going to call this 2, okay, and then I'm going to call this 1, and I'm going to call this up here 2. All right, but I remember that I have a maximum value at the point 1 over e. So let's go ahead and that point's about 1 and then 0.37. Okay, so I'm going to just kind of plot that right about here. I'm going to call this 1 over e. Okay, and then 1 over e squared is a little bit smaller than that. That's going to be right about here. So I have that point here. All right. And then I know that I also have the point 0, 0 on the graph. Okay, that's just my x and y intercept, okay, at the origin. All right, so here's the thing. I know that I increase between 0 and 1, okay? I know I'm increasing right here, and I'm concave down, okay? So let's go ahead and, draw that graph where I'm increasing. Okay, so I'm increasing from here to here, concave down, and then I'm decreasing from 1 to infinity. So I'm going to have to go down like this. But I'm still concave down to 2, okay? So I'm going to draw a graph that's concave down to 2. And then from 2 to infinity, okay, we're concave up, all right? So I'm going to draw a graph that kind of ends up leveling out like this. Okay, so I have my maximum value here, okay, and I have a point of inflection here, okay? And this is just my graph, folks, okay? So we've been, this is something that, we'll be able to do with the second derivative test, okay, knowing what's going on and all that. So it's pretty simple stuff. If you know what you're doing, just putting everything together. I know that's a lot of information, but it's really fun. Let's have a good attitude about it, and let's go ahead and start our homework, and we'll continue on. Thanks. Bye.